first step to solve this circuit on mesh analysis, we convert time domain equivalent circuit to S domain. So for our resistor, there is no change. If 10 ohms, it will be 10 ohms also in S domain. But in capacitor, we use 1 over SC, and for inductance, we use SL to change it to S domain. And for our current source and voltage source, we use Laplace domain. So we use mesh analysis technique. For I1, it's very easy because we found it because the current source is 6 over S, and for I2 is S square plus 4S plus 2 times by I2 minus 2 times I3 equal to 6S, and I3 is negative I2 plus S plus 1 minus for S plus 1 times I3 equal to negative 9.
To find I2 and I3, we must use Cramer's rule. In Cramer's rule, we must form matrices by using the equation of I2 and I3. Okay, the first step is to find the delta matrices and then find the determinant from the matrices formed from the left side of the equation of I2 and I3. And then to find I2, we must insert the answer column to the first column of the delta and then find the determinant. After that, we divide N1 by delta to get I2. For I3, we insert the answer column to the second column of the delta and then we find the determinant. After that, we divide N2 by delta to get the answer for I3. After obtaining the equation for I2 and I3, we can find the I2 and I3 in time domain by using partial fraction. And after solving the partial fraction and using the table, we can solve I2 and I3 in time domain.
From the frequency domain of I1, I2 and I3 that we can get the frequency domain of voltage across the resistor value of 5 ohm and 10 ohm, capacitor of 200 millifarad and inductor of 25 Henry. For voltage across resistor, we use Ohm's law, which is V equals to IR. For voltage across capacitor, we use V equals to I over SC. And lastly, for voltage across inductor, we use V equals to SLI.
After we got all the frequency domain of voltage across 10 ohm and 5 ohm resistors, 200 millifarad capacitor and 25 Henry inductor, we use the same method that we used to find I2 and I3, which is partial fraction, to find the values of numerator of all the voltages. Then, after we got the numerator of all the voltages, we transform the frequency domain of the values of voltage to time domain by using the inverse Laplace transform. This is the answer in time domain for the voltage across the 5 ohm resistor. This is the answer in time domain for the voltage that across 10 ohm resistor, and this is the answer for the voltage in time domain for the voltage that across 25 Henry inductor, and this is the answer in time domain of the voltage that across the capacitor of 200 millifarad.